everyone, this is Pierre Vinet, biochemist, biomechanist, and trainer of world-class athletes. Welcome to my home gym and working space. If you want to know more about who I am, you can read my credentials that are displayed here or visit my website or social media pages. Today we're going to learn how much protein do we need for optimal health and performance. Before jumping into the action, it's important to know that protein is one of the 4 macronutrients which provide energy to the body. Those are protein at roughly 4 calories per gram of dry protein, carbohydrate also at roughly 4 calories per gram of dry carbohydrate, fats at 9.2 calories per gram of fats, and alcohol, which we should obviously try to avoid, at 7 calories per gram. Protein are ingested orally and then broken down with the jaw. It then goes through the stomach, where chlorhydric acid is added to actually start the breaking down of those proteins. Then it basically goes to the intestine, where a number of enzymes, digestive enzymes such as protease, will break down further protein into small chains of amino acids called branched chain amino acids or small peptides, as well as free-form amino acids. In the intestine, amino acids are going to be transported through what we call transporters into the blood and will go into the mainstream. The amino acids are therefore what we call the building blocks of proteins. So they're the building blocks of the protein that we've ingested, which were actually constituents of nature, whether it be vegetables or animal. And then once they're digested and absorbed into the bloodstream, they're in the form of amino acid or small chains of amino acids, which are actually taken by the body to reconstruct a number of constituents of our cells. Those constituents could be enzymes, it could be structural protein, contractile protein, and many other types. There are actually, roughly speaking, 2 types of amino acids. There's what we call the essential amino acids and the non-essential amino acids. The essential amino acids are the amino acids which your body has a hard time or cannot synthesize easily or through standard processes. And the non-essential amino acids, which are actually amino acids that your body can produce from essential amino acids. There's a bit of debate whether essential amino acids are all truly essential, because it's been suggested and theorized that the body can actually produce some of those amino acids, although in lower quantity than we may need. One thing that is also interesting to know is that most vegetable sources do not contain all the essential amino acids in the proper proportions, whether food from animal source such as meat, eggs, and dairy contain all the essential amino acids in roughly the right proportions. When your body needs to create some proteins, for example contractile protein to grow your muscles, and other proteins such as the keratin in the hair or the skin, your body will actually take the amino acids that are available and reconstruct a bit the same way as you would build a word in a phrase using letters. So the body will actually need a certain number of vowels and a certain number of consonants. Will basically need a certain number of letters in different proportions. And it is essential for the body to be able to have the right letters, the right amino acids in the right proportions to synthesize the proteins. When it does not have all those amino acids, it can actually transform some essential amino acids into non-essentials to complete its protein. Also, it is important to know that the body has a store of amino acid in the form of what we call albumin protein. The albumin protein is a protein that circulates in the blood and that acts as a pool of amino acids for your body to repair and construct other proteins. And this protein not only has that capability of pooling the amino acid, it is also responsible for a great deal of what we call the osmotic power of the blood. That means the ability for the blood to retain the water. If you would remove all the albumin in your blood, first you would die. But I mean, if you would remove a good chunk of it, you would lose a lot of water. So it is important to know that basically your body has some stores of amino acids, and although it is suggested that it is important to eat on a very regular basis for optimal health, it is possible to skip some meals and allow your body to still function, still produce protein using the stores of amino acids it has. Let's look at basically two myths here. First, a lot of people believe that there's a maximum amount of protein that you can digest or absorb per sitting, per meal. A number of people will say, the maximum amount of protein that you can store or that you can actually, absorb is 30 grams. This is totally bogus. This is totally false. Your body can absorb pretty much all the protein you will give it. It may take a bit more time, but you can give him a big steak this big and all the proteins will be digested and they will be absorbed. Will they all be used for the purpose of creating muscles? Probably not. Will they all be used for the purpose of creating other proteins inside your body? Maybe not as well. So the body, what it does is it will take all the protein you give him, and whatever it needs it will use. Whatever it doesn't need for construction material, it will actually break down, and actually one of the byproducts of this breakdown is called urea, which is excreted through urine, which gives you the yellow smell and also the yellow look and smell of the urine. So whenever the body doesn't need protein, it will break it down and eliminate it through the kidneys. And it can also use the protein as energy. One thing that you have to keep in mind is that when you drop your calories too drastically, your body will actually favor the use of protein for energy as opposed to use it for material. If your body has the choice between dying from lack of energy and not building muscles, trust me, it will basically not build muscle and will protect itself. And this is especially true if you're typically on what we call a balanced diet or the American Standard Diet, which is the diet that most of us eat. Without going into much details, basically there's two fuels that your body can use to function, two primary fuels. Those are carbohydrates and fats. And if you do not eat a lot of carbohydrate, your body will be trained to use fats. But on the other side, what most of us do is if you eat a lot of carbohydrate on a regular basis, your body will actually preferentially use those carbohydrates as source of energy. And when it lacks of carbohydrates, then it will actually turn down to protein, to break down protein and convert it into sugar through the process that we call gluconeogenesis. And that will actually fuel the body. The downside of this is that basically you're thinking you're using protein to build material, but you're actually not. You're using protein as energy source. And worse, you're actually breaking down the protein of your muscles. And this is one of the reasons why people lose a lot of muscle after going on a diet, is because they cut down so much their calories that their body has to turn and actually break down the protein from the muscle to create energy. And you don't even need to go on a diet for a very hard diet or a very long time. You could just skip a meal, and this happens at certain moments throughout the day and during the night. So again, without going into much details, this is one of the reasons that some people like the ketogenic diet, because a ketogenic diet will actually train your body to use fats instead of protein as energy source, and therefore this will spare your muscles and will allow you to burn fat without losing muscles. Anyway, that was a little parenthesis just to say that the body can actually ingest and absorb pretty much all the protein that you're going to give him. So it's completely false that you can only absorb 30 grams. Now the question is, how many do you really need? It's a totally different question. Now also the standard requirements. Some people say that you need 100 grams of protein per day or 200 grams. Again, this is totally false. Very simply put, it depends on yourself, on a lot of factors. For example, somebody of 100 pounds and somebody of 200 pounds do not need the same construction material. Somebody that is growing, a teenager, needs more protein to build his body, not just his muscle, but a number of components of his body. Whether an elderly which is inactive will need much less protein. Athletes need more protein than non-athletes. Male which have a higher level of testosterone also need more protein than females. Individuals on a ketogenic diet will need more protein in the few first weeks, not too much, but slightly more, to basically compensate for the lack of sugar and allow the brain to basically produce the energy, the sugar it needs using proteins. While after a few weeks, they will actually need much less protein than individuals on a standard diet, because ketogenic diet when you're using a ketogenic diet, the body does not use protein as fuel source. The body pretty much only uses fat, which is what you want. So your requirements greatly vary on a number of things we mentioned, basically age, gender, level of activity, lean body mass, and a number of other factors. What are the traditional methods for evaluating needs? The two most popular methods are basically rough estimates based on the number of calories, total calories ingested, which makes a bit of sense, especially for standard diet, because when your body lacks of carbs, it will actually use protein as energy source. So obviously, if you're going to run a marathon, you might run out of energy, and you may want to provide some extra energy source in the form of protein for your body to use when in need. On the other hand, at the same time, if somebody is 250 pounds of lean muscle, he will typically need more energy because he's got more muscle, but also since he's got more muscle, he probably will need more protein to repair and maintain this huge muscle mass. So there is actually a correlation between the energy expenditure and the lean body mass, and we can extrapolate that or extend that correlation from lean body mass to the protein requirement. So there's an indirect link between the energy expenditure and the protein requirements, and for this reason a number of people actually simply calculate the total number of protein needed based on total calorie intake. The other method is using the lean body mass. The correlation is a bit more direct. But again, those two methods are very good for dietitians, for people wanting to have a very high level understanding of their requirements or estimate of their requirements. However, they do not take in consideration the hormone levels, for example, gender, because a male of a certain weight, lean body mass, might need more than a female simply because he's more anabolic, because he's got more testosterone. It does not take in consideration the gender, the age. It also does not take in consideration the momentary need, which brings me to another point, very important. Today's science, modern science, is digging further and further, and we're not looking at the total requirement per day necessarily as to the momentary requirement. For example, if you've been training and in a few hours following your training, you will need more protein. And if you've not been training, you may not need as much protein at all. When you're on a standard diet, you may want to eat 6-7 times a day to basically make sure that you maintain your glucose level and prevent going in what we call catabolic mode, where you would eat your protein to create energy, as I've mentioned before. But when you're actually on a ketogenic diet and you're not training, you almost need no protein whatsoever, because your body, all it needs is a bit of fuel. And as a matter of fact, your body can actually use your own fat as energy source. So you may need a bit of fat and almost nothing. And when you're training, then you would be needing more. So it's not just so much the total amount of protein that you need for your day, but the total amount of protein that you need around your workout. Although, as I mentioned, your body has some stores, and if you don't eat protein immediately after your workout, your body can take in your pool of protein what we call the albumin, and therefore use that to produce muscles. But just keep in mind that your requirements actually depend on a number of factors, and I suggest you to basically poke your brain and ask yourself, okay, what are the factors that are influencing, as I mentioned, and where do you sit in that basically chart? Finally, one thing that is very important is not just how much protein you need, when you need, but with what. Because if you take protein, and for example, if you take a protein that is very low in leucine, or protein that does not have the necessary amino acid profile, is missing some amino acids, or actually you're not taking any carbohydrate, you may have some of the building blocks, maybe most of them, but you may not have them all, and most importantly, you might not have the trigger. So if you want to grow muscles, there's actually certain triggers, so you need to exercise to basically trigger the anabolic cascade. And one other thing is that you need to actually start what we call the anabolic signaling pathway. This anabolic signaling pathway, called the IGF-1 mTOR AMPK signaling pathway, is actually triggered by consumption of leucine as well as the presence of insulin. So you can see right away that what you need to maximize the effect of the protein is actually to have to ingest leucine at the same time, depending on your body weight, probably 3 to 5 grams of leucine, as well as sugars, ideally, unless you're on a ketogenic diet. But even if you're on a ketogenic diet, you may want to actually ingest sugar right after your workout. Some people will take it right before to fuel their body. During, I prefer to do it after, because I believe that if you're on a ketogenic diet and you're properly adapted, that means your body has been trained to use the fat as energy source. You don't really need fuel during your workout, and you can actually use a bit of BCA, or even better, isoleucine during your workout to give yourself the extra fuel. We can talk about that in another video. But basically, your body will actually use the protein to build muscle more after your workout, and right after the workout, you may want to add leucine, which will actually trigger the mTOR signaling pathway. The mTOR signaling pathway is basically an anabolic cascade which is responsible for building muscle. So it's kind of the signal that tells to your body, okay, now you can take the protein or the amino acid and create protein. Also, you may want to add sugar for 2 reasons. First, because sugar will actually spike your insulin, and the insulin triggers the IGF-1 signaling pathway. It's actually insulin, IGF-1, mTOR, AMPK pathway. So the insulin will actually trigger that pathway, and also will push the nutrients, whether they be sugar or sugar or amino acid, they will push those into the muscles. And also the sugar will provide the fuel. And this is very important. Please keep in mind that you can put all the protein you want. If your body does not have the fuel, it will not build muscle. Your body is very picky. If it does not have extra fuel, it will not build the muscle because it's very energy costing to build muscle. And your body is very sensitive because he knows that, or it knows that if it misses energy, it may die. So your body, it will only build muscle if it has spare energy, spare. So what you have to do is you have to actually ingest calories, ideally in the form of sugar, which is going to spike your sugar and spike your insulin and push all that energy into the cells. So now the cell has both the amino acids and the fuel. And just to close the parenthesis, you may want to have a lot of sugar post-workout with your protein. You may think, oh my God, if I ingest sugar at the same time as my shake, I'm gonna gain fat. Actually, there's excellent studies that were performed by two PhD physiologists, Dr. IV, and I can't remember the other one, and they actually wrote a book on that. It's called Nutrient Timing System. It's very interesting. They did some studies. It's some of the rare studies I've seen on actually bodybuilders and football players. So they actually did studies on real athletes, and they found that when people were ingesting sugar along with their protein, they were becoming less fat. They were losing fat. They were actually leaner than people that were only ingested protein. So keep that in mind. So in conclusion, what I'd like to mention to you is that basically what you got to do is you got to evaluate all the factors that influence the protein requirements. And then what you got to do is you can make some estimates. You can start for endurance athletes with 0.5 grams of protein per pound of lean body mass. When I mean lean body mass is you take your total body weight, you weigh yourself on the scale, you estimate your body fat using skin fold techniques, and you basically remove the body fat from your total body weight. That should give you your lean body mass. Now, you take 0.5 or 0.5 times this, it should give you the amount of protein you need. When I mean protein, I mean the macronutrient protein. I'm not talking about eggs or meat itself. If you want to have 20 grams of protein from chicken, you may have to eat 100 grams of chicken. And I'm here referring to the raw weight. So weight before cooking. You should always weigh your meats before you cook, because depending on the cooking method, you may dehydrate or put some extra water into the protein, and that's going to change the concentration, the ratio of protein, and it's going to be very difficult for you unless you do some mathematics before and after and rule of 3 and to find out exactly how much protein is left. So that's pretty much it. So basically keep those factors in mind and then experiment, and based on the results you adjust. So simply put, you have to learn, and then you have to test, and then you have to adjust. That's it, folks. Hope you liked the video, and looking forward to see you in other videos.